Hi students, have a nice day. In this section, let's continue with the trends in the chemical properties. In the last section, we have seen that the different chemical trends such as valency or oxidation state, electropositivity or metallic character, and anomalous behavior. Valency is the combining capacity of an element, or nowadays it is mostly expressed in oxidation states. The valency of an element in the group is same because of same electronic configuration. In the period, valency increases from left to right, then decreases. Okay, valency is equal to number of electrons in the valence shell, or it is equal to 8 minus number of electrons in the valence shell. Electropositivity is tendency to lose the electron, and it is also known as metallic character. Anomalous behavior means the first element in each group differ from the properties than the rest of the elements in the same group. What are the different anomalous behavior? The anomalous behavior one smaller in size or a smaller atomic radius. Second one is higher ionization enthalpy. Third one is higher electronegativity. Then fourth one is absence of d orbitals, and the last fifth one is high charge by radius ratio. Higher charge by radius ratio. So let's move to the fourth property, diagonal relationship. Okay, diagonal relationship of the second period element and the third period element. Okay, let's write some second period elements. Lithium. Okay, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. This is group 1, this is group 2, 13th group, 14th, 15th, 16th and 17th group. And this is in the second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. The elements occur in the second period. And in the third period, the elements are sodium. Okay, sodium, magnesium, aluminum, then silicon, phosphorus, sulfur, chlorine. The property of the lithium is similar to that of the magnesium. Okay, the property of beryllium is similar to that of the aluminum. And the property of boron is similar to that of the silicon. Okay, when we draw a rectangle or a square, a diagonal, okay, as a diagonal, the relation is diagonal with the next element. So how can we explain the diagonal relationship? Okay, one element is similar property. Okay, one element has similar property of the second element with the next higher group. Okay, so elements having similar property with the second element of the next group, or we can say that some elements in the second period having similar property with the next element in the third period. Okay, next group, third period elements having similar property. So such properties are called a diagonal relationship. What are the different properties? One is similar atomic and ionic radius. Similar atomic and ionic radius. Okay, the first diagonal relationship is similar atomic and ionic radius. Okay, let's take the values. Lithium, the atomic radius is 152. What is the atomic radius for lithium? 152. Beryllium, 111. Okay, 111. Atomic radius is 111. Boron 88. Boron 88. And in the case of sodium, atomic radius is 186. And that of magnesium is 162. Okay, or 160. It is 160 or 162. 160. Okay. Then aluminum is 142. Okay, silicon is lesser. It is nearly 100. So look at the atomic radius of lithium, 152 and 160. Okay, these are in the picometer. PM, picometer. So 152 picometer is similar to 160 picometer. Okay, the difference is 8 picometer. And the next is also similar. So this relationship is known as diagonal relationship. Another one is ionic radius. Lithium having ionic radius, the value is 76 kilo. Okay, what is the atomic radius? 152. What is the ionic radius? It is 76. And beryllium 31. Sodium 102. The atomic radius of sodium ion, okay, B plus. Then it is 102. And magnesium, it is 72. Okay, 72. Magnesium 2 plus is 72. Or the similarity in the ionic radius also, 76 and 72. It's similar. So such properties or such a relation is called diagonal relationship. Next is similar in the ionization enthalpy and electronegativity. Similar ionization enthalpy and electronegativity. And the next is similar polarizing power. Charge by radius ratio is almost similar. That means similar polarizing power. Okay, this is known as diagonal relationship. Okay, and one other thing is lithium forms covalent compounds. Similarly, magnesium forms also covalent compounds. Okay, are you clear? Lithium predominantly covalent in nature. Similarly, magnesium is forming covalent compounds. Okay, then next we move to the trends in the chemical reactivity. Okay, now we just discuss about the trends in the chemical properties. Next we move to the trends in the chemical reactivity. As you know that the properties of an element depends upon the electronic configuration, especially valential electronic configuration. Atomic radius, ionization enthalpy, electronegativity, then electropositivity. Okay, many properties depends upon the electronic configuration of elements. Then we go to discuss about some chemical properties. The first one is oxidizing property and reducing property. What is reduction? Reduction means the element is tend to give electrons. The element is ready to give electron. The property is called reducing property. Okay, chemical properties. Chemical reactivity. Chemical reactivity. The first is reducing property. Reducing property. What is reducing property? One element easily gives electron. The element has higher reducing character. Okay, one element gives electron having reducing character. So reducing character from left to right decreases. Good reducing agents present in the left side of the periodic table. Okay, good reducing agents present in the left side of the periodic table. Alkali metals are good reducing agents. Alkali metals are good reducing agents. Then it is also depends the electropositivity. Okay, more electropositive elements having higher reducing power. Okay, the next is oxidation power, oxidizing property. Second one is oxidizing property. Oxidizing property, which means those elements gains electron. Those elements gains electron. They are good oxidizing agents. Okay. In the period from left to right, oxidizing property increases. Oxidizing nature increases. So halogens are good oxidizing agents. Okay, halogens are present in the right side of the periodic table. So halogens are a good oxidizing agent. Fluorine is a good, okay, the powerful oxidizing agent in the periodic table is fluorine. So halogens are very good oxidizing agent because oxidizing property means it gain electron. The electron gain enthalpy is more. Okay, electron gain enthalpy is more for oxidizing agents. Reducing agent having very low ionization enthalpy. Okay, if ionization enthalpy is low, they are good reducing agents. So this is two properties of elements in the periodic table. Another is oxides. What are oxides? Oxides are binary compounds of oxygen with the other elements. Okay, or the elements which combines to form oxygen, oxides are formed. We know that different oxides are there. Metallic oxides, non-metal oxides, semi-metal oxides or metalloid oxides. Let's discuss the properties of chemical properties of these oxides. As we learned in the lower classes, metal oxides are basic in nature or alkaline nature, and non-metal oxides are acidic in nature. Okay, usually or generally metal oxides are basic in nature and non-metal oxides are acidic in nature. As you know that sodium oxide, okay, sodium oxide, metal oxides, or simply we have to write oxides. Metal oxides are, I just erase these things. Metal oxides are basic in nature, having basic nature. For example, sodium oxide. Sodium oxide is basic in nature. How we have to determine the basicity? If the oxide is soluble in water, H2O. Okay? If the oxide is soluble in water, the solution is alkaline nature. Okay, so 2H2O, 2NaOH. And just dip a litmus paper. A red litmus dipped in this solution is changed into blue color. Okay, so litmus solution or litmus paper used to check the nature of the solution. So generally metal oxides are basic in nature. Next is magnesium oxide. Okay, plus H2O gives magnesium hydroxide. Okay, it is a basic in nature. Next, non-metal oxides. Non-metal oxides are generally acidic in nature. For example, chlorine forms an oxide ClO3. Okay, ClO3. In this, or Cl2O7. Okay, or how to take Cl2O7 plus H2 gives HClO4. HClO4. For balancing, you write 2. Okay, so Cl2O7 is a non-metal oxide. Cl2 also is a non-metal oxide which combines with the water forming perchloric acid. Okay, perchloric acid is formed, which is acidic in nature. You just dip a blue litmus paper, it turns to red. If you dip a red litmus, there is no color change. So this is acidic in nature. Okay, acidic in nature. These are basic in nature. So the conclusion is metal oxides are generally basic in nature, non-metal oxides are generally acidic in nature. And some other oxides are amphoteric, as we know that, amphoteric oxides. For example, aluminium oxide, Al2O3, and arsenic oxide, silicon dioxide, okay. Also zinc oxide, you know that, okay, ZnO is amphoteric in nature. What is amphoteric in character? The solution or the compound which have acidic property as well as basic property. Acidic as well as basic property is called amphoteric in nature. So some oxides having amphoteric nature. Aluminium oxide react with HCl as well as NaOH. Okay, so acidic character as well as basic character of the oxide is called amphoteric oxides. And some other oxides are neutral also. Neutral oxides. For example, carbon monoxide. Remember that carbon dioxide is acidic in nature. Carbon dioxide is acidic. Okay, don't forget it. Carbon monoxide is a neutral oxide. Similarly, nitrogen monoxide is a neutral oxide. Okay, N2O, nitrous oxide, is also known as laughing gas. Nitrous oxide is a neutral oxide. So, oxides can be classified into 4. Okay, acidic, basic, amphoteric, and neutral oxides. Okay, remember that. The next 10 is metallic property. We will discuss the detail. Metallic property is tendency to lose electron. It decreases from left to right and increases from top to bottom in a group. In a periodic table, left to right or across a period, metallic character decreases. And in a group, the metallic character increases. Okay, then we come to the transition metals. Transition metals shows variable valencies, variable oxidation states. Because of it involving valence shell forest electron as well as d electrons in the penultimate shell. So by involving the s electron and the d electrons, transition metals and inner transition metals though generally shows variable valencies, and the other ionization enthalpies are different from the main group elements. Okay, the trend is different. So we will discuss these things in higher classes. That's about the chemical properties. Okay, so today we have discussed about the properties, diagonal relationship, reducing nature, oxidizing nature, metallic character, and the oxides, the nature of the oxides. Metal oxides are basic in nature, non-metal oxides are acidic in nature. However, some oxides behave as amphoteric and some non-metal oxides are neutral. Okay, so you collect all these information. Okay, let's do some problems based on the ionization enthalpy. The first question, the ionization enthalpy of lithium is 520 kilojoule per mole. Calculate the amount of energy required to convert 70 milligram of lithium atoms into gaseous state to its ions, lithium ions. Once again I read the question, you please write on it. The ionization enthalpy of lithium is 520 kilojoule per mole. Calculate the amount of energy required to convert 70 mg of lithium atoms in gaseous state into Li plus ions. Okay, very simple question. What is ionization energy? The energy required to remove the loosely held electron from the valence shell is called the ionization energy. The ionization energy of the lithium is given. Okay, IE of lithium is given. It is a 520 kilojoule per mole. Okay. 1 mole of lithium means 7 gram of lithium. Okay, 7 gram of lithium. The molar mass or atomic mass of lithium is 7 gram. But we have given the mass of lithium. Mass of lithium atoms is equal to 70 mg. What is 1 mg? 1 mg is equal to 10 raised to minus 3 gram. So it is converted into 70 into 10 raised to minus 3 gram into standard form 7 into 10 raised to minus 2 gram. For 1 mole 520 kilojoule is required. Okay, for 1 mole of lithium 520 is required. But we don't have 1 mole. It is 7 into 10 raised to minus 2 gram. Then let's find the number of moles. Number of moles of lithium is equal to mass divided by molar mass. Mass in gram divided by molar mass, that is 7 into 10 raised to minus 2 gram divided by 7. That is equal to 1 into 10 raised to minus 2 moles. Okay. So for 1 mole, okay, 1 mole of lithium atom, the ionization energy or the energy required to ionize lithium is equal to 520 kilojoule per mole or 520 kilojoule. How much more we have? 1 into 10 raised to minus 2 mole. Therefore, the energy required to ionize 1 into 10 raised to minus 2 mole lithium atoms into lithium ions is equal to, okay, for 1 mole it is 520 kilojoule. So how much for this? It is 520 kilojoule into 1 into 10 raised to minus 2 minus 2, that much kilojoule. How much it is? Okay, you just do it. 5.2 kilojoule per mole. 5.2 kilojoule. That's the answer. Okay, a very simple problem. This type of problems are usually asked. And the second question. The second question is, the ionization potential of hydrogen is 13.6 electron volt. Calculate the energy required to produce hydrogen ions from 0.5 gram of hydrogen. Okay, similar problems, but the energy is given in electron volt. Okay, the ionization potential, once again I read the question. The ionization potential of hydrogen is 13.6 electron volt. Calculate the energy required to produce hydrogen ion from 0.5 gram of hydrogen. Okay, what is ionization energy? As we know that ionization energy is the energy required to remove the electron from the valence shell. Hydrogen has only one shell, that is first shell. So the only one electron present in the hydrogen, the energy required is called ionization energy. Here ionization potential is given. So second problem, hydrogen gas plus 13.6 electron volt gives hydrogen plus gas plus 1 electron. Okay, that's the data is given, and the mass of the hydrogen also given. Mass of hydrogen atoms is equal to 0.5 gram. Mass of hydrogen is 0.5 gram. Then, as we know that 1 electron volt is equal to 1.602 into 10 raised to minus 19 joule. And we have to express the energy in joule. Joule per mole. Okay. So to convert into mole, you multiply with 6.023 into 10 raised to 23. And is converted into kilojoule. 1 electron volt is equal to 96.49 kilojoule. Okay, this is the value. Or we have to write 96.5. 49 is written by 5 kilojoule per mole. Then what about the energy required? The energy is equal to 30.6 electron volt into 96.5 kilojoule. Okay, dimension analysis divided by electron volt. Electron volt is cancelled, and the energy is equal to 1312.4 kilojoule per mole. Okay, 1312.4 kilojoule per mole. And this is the energy for 1 mole of hydrogen. We don't have 1 mole, we have only 0.5. So 1 mole of hydrogen is equal to 1 mole of hydrogen is equal to 1 gram or 1.008. You take it is 1. The number of moles of hydrogen, is equal to 0.5 divided by 1. Okay, that is 0.5 mole. 1 mole required this much energy. So what about 0.5 moles? The energy required. Write complete. The energy required to convert 0.5 gram hydrogen into hydrogen ion is equal to 1312.4 kilojoule into 0.5. What is 0.5? Half. Okay, 1/2. So the answer is divided by 2. Answer is 6. Then 5. 6.2 kilojoule. That much energy. Okay. 0.5 gram hydrogen required 656.2 kilojoule energy. Okay, so that's about the third chapter. We successfully complete the third chapter. Some problems, not problems, some exercise, worked exercise are given in the textbook. You please go through it, and any doubt you can ask. Okay, in the next section we will start the new chapter, chemical bonding. Okay, you just revise the type of bonds as you studied in lower classes, covalent bond, ionic bond, etc. Okay, so we will see in the next section. Thank you.